So now we're going to be talking about indefinite integrals, okay, and explaining what the difference between an indefinite integral and a definite integral is in the next few lessons. So finding the antiderivative, as I kind of suggested, is more commonly known as integration, okay? But what we're going to do here is have a look at how you can get a little bit tripped up sometimes with these things called indefinite integrals. Let's have a look. So I want you to find the derivative of all the following functions. Pretty straightforward. Okay, x cubed is going to be 3x squared. Fine. X cubed plus 2 is also going to be 3x squared. Brilliant. 3x to the power of 3 plus 8, also 3x squared. Bit of a pattern here. And then this last one, x cubed plus c. Well, c doesn't have anything to do with x, so that's just going to go to 0. So this is going to be 3x squared. Amazing. Easy peasy. Genius level. But what's going to happen here? So I'm saying find the integral of the following function. Well, hang on a sec. We just figured that out before, and we know for every single one it was 3x squared. Okay. But if integration is just the opposite, then how do I know which one this one's meant to be? Okay, because is it x cubed plus 2, x cubed plus 8? You know, how am I meant to know which one to pick? Question marks. Okay, so the answer to the previous question is this thing called the constant of integration. So if I ask you this question here, what is the derivative of f of x is equal to x to the power of n plus c? You'd be like, well, pretty straightforward. F dash of x is equal to multiplying by that power and to minus that power minus 1. Then obviously c has no x component, so it just goes to 0. So what we need to think about here is we need to compensate for these things that might not have x components in them. They might not be differentiable. So what we do is we add in this component called plus c. So this would become f of x equal to x to the power of n plus c. And I'm going to show you a Desmos graph and talk you through it a little bit more. Okay, so I've got this function here, t of x, which is equal to 9x squared minus 8x, but that's not important what it's equal to. What I've done here is I've been able to integrate this function, okay, here, and then I put this plus c sign on, okay. So what this does is it integrates this function to here. And the thing I really want to make clear here is no matter what value you make c, see I'm changing c here, it just shifts it up and down the y-axis. It doesn't actually affect the shape or the of the graph at all, okay? And it doesn't affect the derivative graph. The derivative graph always stays in the same place no matter what c is, right? And if c is 0, it just doesn't move it at all, okay? So sometimes c could be 0 when you've figured it out. We'll go into that later. But this is really what it means. So it's the part of the graph that moves it up and down. It has no effect on the left or right. I'll attach a link to this so you can have a play about with it. But you can